Stephanie here from beapython.dev, doing some more live Leet code coding contest challenge problem things. Alright, number 82 here. Remove duplicates from a sorted list. This is the medium version of the problem. I think I kind of know what's going on here. Given a sorted linked list, sorted is important because that means values of the same value will actually be right next to each other, so we can kind of like skip through them. Delete all the nodes that have duplicate numbers, leaving only the distinct numbers from the original list. So if we have an input 1, 2, 3, 3, 4, 4, 5, the return list will just be 1, 2, 5 because the 3 and the 3 will be duplicated if deleted against each other. Same with the 4 and the 4. So this problem, to me, it feels like we're just kind of testing the ability to recognize what a list means as far as like duplicates, deleting them. To delete two different nodes would basically take the pointer for this node here and have it point to 4. Well, not actually 4 because 4s are duplicates, but when we're going through our algorithm, we'll see the 3 and the 3, so we'll have 2 point to 4, and then we'll see that 4 and 4 are duplicates, so we'll take 2 and point it to 5. And then essentially when the function goes out of scope, these 4 nodes here will end up getting deleted by the garbage collector because they're not referenced by anything anymore. So the basic concepts of our algorithm, we're going to iterate through the list, we're going to keep track of a previous pointer. When we get to some duplicates, we'll just skip over them for our pointers. We'll have 2's next pointer value will go to 4, and then 2's next pointer value will go to 5 after we see these are duplicates. So at least that's kind of the thinking behind it. So let's see if we can actually turn this into code. You may want to check your inputs. I don't know if that will be a thing here. I'm assuming if head equals none, well, it might turn us in something like this, where we get this kind of input. If head equals none, return head. So I think we want to initialize, well, previous will equal to none. And then while current node equals head, so while current node, so this will keep iterating through our list while we actually have a head, because at the end of our algorithm, to determine if it's a duplicate or not, we're going to set current equal to the next, and if the next equals none, then this is going to evaluate to false and it will break out of the loop. So what do we want to do with this? So while current dot next, while current dot val equals current dot next dot val. So this will see if our current node, if the value is the same as the next node. So this will allow us to keep skipping over these, so we can move our pointer as we kind of talked about before. So we haven't actually set anything yet, because if we have this input case, we're going to want to do something special. So let's think through what will that do. So this will keep iterating until we get to this one, I think. So this will be our current. So the current would be a duplicate of the previous if we're in this, I think. We may want to set some duplicate flags too. Is duplicate equals false, I think. And while we're in this loop, we want to do is dupe equals true. And then this isn't always going to be true, because if we have 1 on 1 and then 2 to 2, we're not actually going to have a current node or a head node. To return equals head. So we want to keep track of the head pointer in case we end up deleting the head pointer. So I think this loop will be used just for moving our current pointer in the event we do get these duplicates. Do we want previous to be ahead too? So this might be response equals previous equals current equals head. This might be overkill, but for now we'll see how many of these variables we actually end up using. Current equals current.next. So again, this will move our pointer along. It will set the duplicate flag to true. It'll break when current.next.val equals something different than what we're currently looking at.
Forward collision warning with emergency braking
Standard if isDupe equals true.
Part of Kia's tough and ready lineup of SUVs. Hurry into Kia's President's Day sales event and lease the 2020 Sportage LX all-wheel drive for $159.
So actually, I think we do want our our response to be none. And not response. I don't know if we actually want to set this yet because of that case that we just said. We might be setting the head node too early. Is that true? So previous doesn't actually equal anything if it's none. So I'm not thinking very well with my previous pointer and my response head pointer. Mainly because of the case if we have this, we need to know that these are all duplicates and that this is right. But then where that really gets tricky is when we have this. Because our algorithm is naturally going to want to set this to 3. So we might be able to single pass checking for the next one actually. So we kind of need to go through this one more time. So after we break out of this, maybe we want to do something like if isDupe continue. So I think that will literally just go into the next cycle and it will just skip these completely. In which case we don't need this piece of code at all. And the head node still won't be set yet. So if we get through all of this fun stuff, then that means the node that we're looking at is a different value than the node in front of it. Okay, and then if previous, I mean, I guess you could say if not previous, previous equals cur. I think you want to say previous equals head equals current, because if the previous isn't set, then the response isn't set. Actually, this is the response. Okay, so we're going to want to make sure our previous pointer points to our head pointer. So previous equals current. Previous equals current. Current.next. Current equals current.next. So this should set our pointers correctly after we skip over these guys, which are the duplicates here. And then it should go into our next piece of code here. If this is a duplicate, do we need to change our current at all? I think we do. Current equals current.next. I think this may work. Let's go ahead and run it. Okay, so somewhere I am not incrementing my pointer where I think I am. So I think it's right here, if not previous. So this should actually just be outside of this loop. And we could almost make it a little cleaner by doing this. I mean, we can skip over this and just have it fall through. We have to change the logic a little bit. That doesn't really get us any huge gains, so we'll just go ahead and break the loop anyways. That all should be fine there too. None-type object has no attribute val. Okay, so this happens when we get to the end of our list. Okay, so I think for this you just need to do while current.next and current.val equals current.next.val. Yeah, this logic should still work even if we end with duplicates. Alright, so that skipped over like I thought it would. We still have this potential edge case, and then we have an edge case where it might end with duplicates. Because if it ends with duplicates, I don't think this pointer is getting set correctly. Because we're going to fall through here. IsDupe is going to be true, but we're going to be at the end of our list. So there's not going to be a while cur. So I think we need to do if is dupe and not current.next. So for that, at the end of the list, and there is no current.next value, we need to just delete this pointer here. So that should be our current pointer. Or the previous pointer, actually. We need to delete the previous .next pointer and set that to none. So it's kind of abstract, but we'll see if this actually works. Okay, cool. So that worked like I thought it would. We get in the case where current.next could be potentially nothing if we end up having 6 and 6. So somehow we need to delete these two elements. We'll go through our skip through logic, and our current.next will be equal to none because we'll be right here. So we need to take this 5 next pointer and set that to none. And then when we go out of scope of this delete duplicates function, the garbage collector will just delete these two nodes. So that should cover that edge case. And then we have this edge case too, where it starts with duplicates, which we should have already handled in this skipping logic here. So let's run this. Okay, cool. So it deleted the ones like we thought it would, because instead of using 1 as the original head pointer, we are skipping through this. We're setting our response node to be this 2 value. So that'll be the start of our list. And then we go ahead and return that. So I'm going to submit this. Hopefully we don't run into any crazy edge cases that I didn't think through already. If we do, we'll just debug through it and solve it. Alright. So this is if we have 1 and 1. This would also happen if we have 1, 1, 2, 2. So where our list is all duplicates. So yep, that's definitely an edge case we didn't really think through when we submitted this. So this will only ever happen if we get to the end of our list. So I think we can do if not previous. So if previous is still none the whole time, we've never initialized it. That means we've only ever seen duplicates. So if not previous, what are we actually supposed to return if there is no node? Do we just return none? Because you can't really you can make an empty list with the value of none. This is kind of unfortunate. I don't know what it expects us to return. I guess we can just do this. We can manually set our test case to be a node or a list of duplicates. Go ahead and run this. It'll tell us what it expects. I think we can just return none here, honestly. 1, 2, 3, 4. So generally a tab is 4 spaces. You can set your tabs to be equal to 2 spaces too. I think you can set that in here. Yeah, right here. Okay, whatever. Hopefully this is the correct response for a completely duplicated list. Okay, cool. So returning none did give us the empty array / list that it was expecting. Alright. Hopefully there's no other crazy edge cases. Alright, accepted. Perfect. I hope that all made sense to you. If you have any questions about the logic or you want to talk about anything more, actually this is amazing. Our runtime is 24 milliseconds, so faster than 99.90. Memory usage, constant memory, because we're replacing everything in line. There might be some other answers in this that are pretty dirty. As you can see, I haven't done this problem before, so happy to go through a completely new problem with you guys live. And like I said, if you have any questions, leave them in the comments. If you like this video, please go ahead and smash that like and subscribe. That'll really help me out to build the channel and develop the blog. So have a good day or evening or night or whatever you guys are doing. Just have a good one. Peace.